Hello everyone. My name is Kunal, and I'm your mathematics tutor. And currently, we are actually reading about the indefinite integral. And today is our lecture 4. So, in last class, we actually deal with the technique of integration by parts rule, जिसमें हमने प्रोडक्ट के फॉर्म में जो भी रहता था इंटीग्रेंड उसे सॉल्व करने के लिए सीखा था. And today we are discuss some problem in it and some its special case, and then we move to the some standard algebraic integration basic formula. Okay, so in last class we left some question, so we first deal with it, then we start our new topic. Okay, so these are some topic, these are some question which we deal first. Let me check. Okay, am I audible? Okay, so our first question is like x square e to the power x or x cube e to the power x. How to solve this question? So we first, I can write here as well. Okay, so here we can understand that here is from Eilert rule. We know that our first we assign our u and v. First we assign our actually u and v. So here we have two function. One is algebraic function and other is exponential function. So we know that we actually allot u to algebraic function because it's come first in the sequence. So what we do, we just apply the by parts rule. So it's something look like integration of uv is equal to, we take out of the u and then we integrate and then minus integration of basically differentiation of u with respect to x. Here we doing with respect to x, and again we integrate the v dx, and then we integrate the whole integral. So when we apply here, so what happened? Let me solve this question. So here u is x cube and v is our e to the power x. I hope now it will be okay. So let me change the color as well. Okay. Okay. So let me erase it first because it's too hectic. Then I have to solve this. How to apply these all? You all understand that how to assign u and v by Eilert rule, and then we have to apply the by parts formula. So let me apply here the by parts rule. It will be fine. Let me write. Okay. So let me solve here. Here our problem is like u is our x cube and v is our e to the power x. So we know that the integration of uv dx is equal to, we first take u outside the integral and then we integrate v first and then minus, and then we differentiate u, and then we again integrate x, and then we overall integrate this with respect to x. So let me solve this. Okay, so what we have to do, I have to do like first x cube, we have to take outside the integral, and we have to integrate the e to the power x with respect to x, obviously. And then I have to differentiate the u. And what is u? And the different u is x cube, and the differentiation of x cube is 3x square. And then again we have to integrate e to the power x with respect to dx, and this whole again will be integrated with respect to the x cube. So what I get x cube e to the power x, this part, and then when we integrate e to the power x here, so 3x square e to the power x. Now if you look here, it's again come into the form of u dot v, some product function, right? So again, we apply by parts here. And when now, because here again, the function is one algebraic function and exponential function. So our assigned u, v will remain same because function is again algebraic and exponential. So our assigned u and v value will be same here. So we again apply here uh, by parts rule. So it will be like x cube e to the power x. This is, and here we have to take 3x square outside the integration and again integrate e to the power x dx, and minus, we have to differentiate. Now our new u will be 3x square. So we have to differentiate this as we done here, as we actually done here. So here will be like 6x. And again, we integrate to the power x will be look like that. So when we look here, it will be like x cube e to the power x minus 3x square e to the power x. And if you look here again, 6x e to the power x dx. Again, it's come in the form of integration. It remain in the form of integration with product of two function in which one is algebraic function and one is exponential function. So again, we have to apply by parts here. So what is the result now? These all are same. 3x square e to the power x and plus we have to take 6x outside the integral, and again we have to integrate e to the power x dx, and then minus we have to do like differentiation of 6x, so it will be like 6 ex dx, right? And when we solve this, what we get? We get x cube e to the power x minus 3x square e to the power x plus 6x e to the power x minus 6 e to the power x. And when we take common, we get this result and some plus constant. I hope you'll understand that. Now the situation is हमें बार बार बाय पार्ट्स लगानी पड़ रही है क्योंकि बार बार अल्जेब्राइक फंक्शन रिपीट हो रहा, लाइक कॉम्बिनेशन सेम ही जा रहा है, एक अल्जेब्रिक फंक्शन और एक एक्सपोनेंशियल फंक्शन, एक अल्जेब्राइक फंक्शन एक एक्सपोनेंशियल फंक्शन. सो एग्जाम में लाइक जेई जैसे एग्जाम में इतने बड़े में सॉल्व कर पाना, दैट विल बी not fair for students. So what we do, we apply some short method. So let us look on some shortcut method, like how to solve it in easy way. So let me erase it first. So what is actually trick in it? Like we have, if there is an algebraic function, let me erase it first, then I'm explaining that thing. Okay. So this is our theory actually. Okay. So what we do, if we have a function, as I mentioned here, if we have a function like uv, in term of uv, as I told you here, let me shift it to some right side. Okay. Let us suppose we have a function uv in terms of product, two function in form of product. So what we do in by parts, we first assigned u and v according to the Eilert rule. And then we take u outside the integral first and then integrate v, then different, and then integrate the whole, first differentiation of u and then integration of v, whatever product we get here, we integrate the whole thing. So this is our by parts rule, right? So now, so if there is a function which differentiation diminish at one step, at any step, basically what it means, एक ऐसा फंक्शन जो कि डिफरेंशिएट कंटिन्यूअसली डिफरेंशिएट होके सेमी फंक्शन बन रहा, सेमी टाइप का फंक्शन है, एंड इट्स डिफरेंशिएट कंटिन्यूअसली डिफरेंशिएटिंग होने के बाद एक कांस्टेंट वैल्यू हमें मिल रही है, एंड इट्स ओनली this formula is only valid for algebraic function because if we take x cube, okay, and if we continuously differentiating with what we get, we first get 3x square, फिर से हम इसे डिफरेंशिएट करेंगे, what we get 6x, एक बार और डिफरेंशिएट करेंगे, what we get 6. So its power decreases at each single step by 1, right? तो क्या हो रही है कि if we assign this as u, let us suppose that a function is given like जो भी हमने सॉल्व करी पढ़े में एक्स क्यू ई टू द पावर एक्स, जहाँ पे ये हमारा u था अकॉर्डिंग टू आइलेट रूल, एंड दिस इज आवर v. सो ईच स्टेप में क्या हो रहा कि एक्स क्यू जो है वो उसकी डिफरेंशिएशन डिमिनिश हो रही है ईच स्टेप में, एंड फाइनली लीड टू अ कांस्टेंट वैल्यू. सो व्हाट वी डू, दिस इज आवर फॉर्मूला. For this formula is only applicable for algebraic function, in which what we do, we just differentiate u partially and integrate v partially. So what I'm saying, with the plus minus sign, so what I do is like if this is a problem, like e to x cube e to the power x, हमें पहले चेक क्या करनी है कि पहले तो u मेरा अलजेब्राइक फंक्शन होना चाहिए, एंड दूसरी बात उसकी डिफरेंशिएशन कंटिन्यूअसली डिमिनिश होनी चाहिए. डिमिनिश मतलब इट फाइनली लीड टू अ कांस्टेंट वैल्यू. सो हाउ टू अप्रोच दिस? देयर इज अ डायरेक्ट ट्रिक. वी पार्शियली differentiate u and partially integrate v. This is our u and this is our v. First we assign uv according to the Eilert rule, and then what I do, x cube, first integrate v, and then with the plus minus, and here is plus, so here will become minus. So minus, now I differentiate x cube, 3x square, and double integrate e to the power x. And now here is minus, so here will be plus. Again differentiate it. So what I get, 6x, triple integration of e to the power x, and here will be plus, so next will be minus 6, 4 integration of e to the power x. So what I get here, x cube e to the power x minus 3x square. When we first integrate e to the power x, we again get e to the power x, and and again we integrate to the power x, so again we get to the power x plus 6x e to the power x minus 6 e to the power x. So I hope you all understand that. We discuss some more example in it, so hope you understand it as well. Okay, so now let's move on to the some example, whatever we read here. Okay, so let us suppose here is our example. What is it? It is x to the power 5 and e to the power x. We know that what पहले हमें देखनी क्या होती है, हमें देखनी होती है कि हमारे पास एक अलजेब्राइक फंक्शन होना चाहिए जो कि है, और जो कि एक्चुअली में आइलेट के अकॉर्डिंग अगर देखते हैं, एंड दूसरी मेरी एक्सपोनेंशियल फंक्शन है. तो अलजेब्रा आइलेट के अकॉर्डिंग वी असाइंड u to the x to the power 5 and v to the e to the power x. So what we know, and the differentiation of x to the power 5 step by step diminish. That means it reach to a constant value. अगर continuously x to the power 5 को differentiate करते रहते हैं, so it reach to a constant value. So what is direct method? What we do, we partially differentiate u and partially continuous integration u, v. So what we do, x to the power 5, first we wrote, and then integrate e to the power x with plus minus sign. Here will be plus, so next will be minus. We put minus here and then differentiate this. So 5x to the power 4 and double times integrate e to the power x. Here minus, so we put plus here, and again differentiate 5x to the power 4, so it will be like 20x cube, triple integration of e to the power x, here plus, so here will be minus 60x square. We just differentiating this 60x square 4 times integration of e to the power x plus 120x. Look at this, plus minus plus minus plus. So next will be, and 5 times integration of e to the power x. Okay, here times, and then minus 126 time integration of e to the power x. And we know that e to the power x integration will be e to the power x itself, right? So if we start integrating it, so what we get, x to the power 5 e to the power x minus 5x to the power 4 e to the power x plus 20x cube e to the power x minus 60x square e to the power x plus 120x e to the power x minus 120. So whatever we get, and then take x e to the power x outside, so we get the same result here. I hope you all understand that. Let me erase it. So this is our basically standard formula for algebraic function, जो कि continuous differentiation के बाद एक constant value को reach करता है. तो ये एक ही दो केस में अप्लाई होता है, बट यूजफुल है, इजी, जल्दी और फास्ट बन जाता है. So now let's move on to next theory portion actually, which is actually more important here, and we have to read, which is like spatial integrand. So here is our some classic integrand, and we deal with it. क्या है नहीं है इसको एक बारी देखते हैं. Okay. So these both are our classic integrand, and it is quite effective in solving complex integrand. So एक बारी देख लेते हैं. If you look at this function, what is it? This is our fx plus x plus differentiation of fx, right? यही लिखी है ना. If we assign, अगर हम u fx को u बोल देते हैं, तो this will be like du, or u dash we can say, this no, u dash we can say. And if we assign x as v, so here obviously 1 multiplied, so differentiation of x is 1, so here v dash is written. So क्या लिखी हुई एक बारी फिर से अगर इसको हम इसी इंटीग्रेशन को लिखते हैं, so what is written, v dash u plus u dash v, right, dx. And we know that in differentiation हमने पढ़ा होगा, आपने पढ़ा होगा, like differentiation of u v क्या होता है in product rule. First we take u, first we differentiate v and take first we differentiate u and then take v as remain, and then we differentiate v and take u as remain. The same thing written here, यही तो लिखे ना यहाँ पे. So we can write it as integration of uv dash dx, and when we integrate this, what we get, uv plus constant. So ये काफी यूजफुल होने वाला है आगे वाले प्रॉब्लम में. बस हमें देखनी क्या होती है, ये एक फंक्शन समथिंग a प्लस बी के फॉर्म में लिखा हुआ है. इफ यू टोटल असाइन दिस फंक्शन एज a एंड b, तो ये कुछ a प्लस बी के फॉर्म में लिखी हुई है, जहां पे एक फंक्शन, जहां पे एक पार्ट में एक ओरिजिनल फंक्शन एंड सेकंड पार्ट में उसका डिफरेंशिएशन, एंड जो सेकंड फंक्शन है उसमें एक पार्ट में ओरिजिनल फंक्शन एंड सेकंड पार्ट में उसकी differentiation है. So how we uh, solve this type of question? So we know that in differentiation by product rule will be like something like that. First we take one function as remain and differentiate the second function and repeat this process for the second time. So यहाँ पे हमें वही करनी थी. So the next thing is what we do is fx it's remain. So now look at some problem. So problem से examples अच्छे से clear हो जाएंगी. So that will be quite helpful. So look at some problem, first erase it. And let's move to the problem. I'm again repeating calculus is a parts of math which mostly based on practice. जितना ज़्यादा practice उतनी ज़्यादा एक चीजें अच्छे से समझ में आने लगती हैं. क्योंकि इसमें theory कम है and practice ही ज़्यादा है. So now let's move on to the next part. Okay. So इसकी proof वही है जो भी हमने करा product rule से आ जाता है. So now let's move on to the first problem. Okay. So what is the here given? Like x e to the power x1 plus x square. Okay. So what can we do here? One thing we can do like we can add and subtract one such that in denominator power reduces. Basically, look, 1 by x integration we know, right? It will be like ln mod x plus c integration of okay. इसकी integration हमें पता है. तो if here the power is 2, so we try to reduce its power. So we can write x plus minus 1. Simple manipulation है. We can write it as x को x plus 1 minus 1. And then what I do, e to the power x divided by 1 plus x square. So if we look here, e to the power x by 1 plus x minus e to the power x by 1 plus x square. If we open it, अगर इस फंक्शन को हमने खोला तो कुछ इस तरीके से आएगा, right? dx. And now look at here. If we assign 1 by 1 plus x as u, so we know that its differentiation is minus 1 by 1 plus x square whole square, right? इसकी differentiation यही होती है. And e to the power x differentiation will remain e to the power x. If we differentiate this function, it remain e to the power x. So what I'm saying, कि ये जो function है 1 by 1 plus x, इसकी differentiation यहाँ पे आई हुई है minus 1 by 1 plus x square. So if this function is u dash is here, and if this function is v, so v dash is here. So it's again form like uv dash plus u dash v. What where u is where actually u is 1 by 1 plus x and v is e to the power x. So what is our integration? We read actually uv is our integrand value. So here uv plus constant where u is our 1 by 1 plus x e to the power x. So this is our integration value. Okay. I hope you'll understand that. यहाँ पे ये uv dash आता है like product rule के according, and then we integrate this function, we get uv plus constant. So our integration value will be uv. I hope you'll all understand that. एक दो प्रॉब्लम और देखते हैं जिससे क्लैरिटी अच्छे से आ जाएंगी. Let me read it. Move to the next example. Okay. So it is power x 1 by 1 plus x is the answer. Okay. So now move to the second question. What here written is, okay. So here our question is sin x plus x cos x. We have to actually integrate sin x plus x cos x. And if we know that देखो प्रैक्टिस जितना करोगे ना उससे चीजें समझ में आ जाएंगे कि साइन एक्स की डिफरेंशिएशन कॉस एक्स होती है और एक्स एक फंक्शन है, इसकी यहाँ पे डिफरेंशिएशन 1 लिखी हुई है. So if we assign x as u, so our u dash is here, and if we assign v here, v dash is here. So it's again in the form of uv dash. So when we integrate that, what we get? uv plus c. And what is our u? Sin x. And what is our v? X. So x sin x plus c. It's easy, right? बस दिख जाना चाहिए कि कैसे हो रहा है. लाइक उसकी डिफरेंशिएशन वहां पे है एंड इसकी डिफरेंशिएशन यहाँ पे है. सो जस्ट बाई इनवर्स ऑफ product rule, it will be like uv ka integration, so it will be like u. I hope you'll all understand that. We look into one more problem, then we move to the standard algebraic integration and its proof as well. Okay, so let's move to our today's lecture. I hope you'll all understand enough. Well, okay. So these are some more example. If you want to practice, you can. So let us solve one more example in the form of that. So our first question look like e to the power x 2x plus 1 2 root x dx. So what I have to do? We have to first break it. ऐसे दिखेगा नहीं तो first break it. Let me make some space here and try to solve this all question with own. So e to the power x and try to break it. When we break it, what we get? Root x and plus 1 by 2 root x. Now look at here. What is the integration? What is the differentiation of root x? It will be like 1 by 2 root x. We know that. So if we differentiate this, so if we assign u here, so u dash is here, and e to the power x is multiplying both. So if we do v, and we know that the differentiation of e to the power x is e to the power x itself. So again here form u v dash plus u dash v integration. So it again will be like uv plus c. So what is our u? Our u is root x and v is e to the power x plus c. So this is our integration. I hope you all understand that. It's easy, right? So try to practice this all question. And solution is already given in it. So try to hide the solution and solve it. Because all based on special integrand जो आज हमने भी पढ़ा है. Now let me read it. Okay. So now today we move to the next part. These all are practice question. Try to solve this. So now we move to some trigonometric substitution. Like some special type कि कहाँ पे कौन सी वैल्यू को सब्स्टिट्यूट करनी है. तो वैसे खुद से समझ में भी आ जाना चाहिए, बट अगर प्रैक्टिस करे होंगे तो. बट अगर नहीं तो देखते एक बार. लाइक इफ वी सॉ समवेयर, अगर कहीं मुझे फंक्शन देखने को मिल रहा है विद द फॉर्म ऑफ रूट अंडर ए स्क्वायर माइनस एक्स स्क्वायर. Like look at this function. If I have to integrate, let us suppose this function a square minus x square dx. और इसे इंटीग्रेट करने के लिए ना देखे, इसके साथ कोई और भी फंक्शन दिया हुआ हो और उसे इंटीग्रेट करने के लिए कहा, तो लाइक हाउ टू डील विद इट. सो व्हाट वी डू, लाइक वी हैव टू इंटीग्रेट x root under a square minus x square. So we know that some basic trigonometric substitution. Like here we can put x is equal to a sin theta or a cos theta. And when we put that, what we get? A sin theta, we substitute here a sin theta, and root under a square minus a square sin square theta and dx will be like, if we substitute x is equal to a sin theta, so dx will be like a cos theta, like a cos theta, right? A sin theta. And when we solve this, what we get? We know that 1 minus sin square theta will be like cos square theta. So when we solve this, we get a cos theta d theta, right? So when we solve that, what we get? A q sin theta cos square theta d theta. And we know that we can भी हमने पहले ही से पढ़ रखा है सब्स्टिट्यूशन में कि क्या करते हैं, लाइक एक फंक्शन को डी लेके, और सब्स्टिट्यूशन टेक्निक हम इन सेकेंड लेक्चर में मैंने पढ़ाया था, उसमें क्लियर करी थी कि कहीं भी अगर वी कैन यूज द सब्स्टिट्यूशन टेक्निक जहाँ पे भी कॉम्प्लेक्स फंक्शन आने लगे, तो यहाँ पे कॉम्प्लेक्स इंटीग्रेंड मेरे को दिख रहा है, तो वी कैन सब्स्टिट्यूट कॉस थीटा टू टी, सो इट्स डिफरेंशिएशन विल बी माइनस साइन थीटा, and then we can proceed it to solve. So you can solve it. तो बेसिकली मैं यहाँ पे सिंपल बता रहा था कि अगर इस तरीके का फंक्शन कहीं पे भी दिख जाए, सो ट्राई टू सब्स्टिट्यूट ए साइन थीटा ए कॉस थीटा. अगर ए स्क्वायर प्लस एक्स स्क्वायर दिख जाए, देन ट्राई टू सब्स्टिट्यूट ए टैन थीटा ए कॉट थीटा. ये बेसिकली सब्स्टिट्यूशन ही है, फंक्शन दिख जाए कहीं पे भी, सो ट्राई टू सब्स्टिट्यूट दिस, जिससे इंटीग्रेंड कॉम्प्लेक्स इंटीग्रेंड हमारा फेवरेबल इंटीग्रेंड में कन्वर्ट हो जाएंगे. आई होप यू ऑल अंडरस्टैंड दैट. सो we first take to the a square minus x square root under, and wherever हमारे पास a root under a square plus x square होगा, so we try to put x is equal to a sin a tan theta a cot theta. कहीं पे भी x square minus a square होगा, so we try to put sec theta and cosec theta, because we know that अगर हम अंदर में देखें तो हमें पता है कि cosec square theta minus 1 equal to cot theta, cot square theta आता है, right? So if we apply that, this whole value come out of the root, जो भी अंदर में प्रोडक्ट रिजल्ट आएगा वो रूट से बाहर आ जाएगा. तो वन वे ऑफ अप्रोच दैट कि हमें बस रूट से बाहर निकालनी होती है, लाइक आप कुछ भी पुट करके वैल्यू, एंड दैट विल बी फेवरेबल, एक ही है, एंड वो है सेक थीटा और कॉसेक थीटा. अपनी अपनी अप्रोच होती है, जैसे भी समझ में आए. जस्ट दिमाग में बस यही रखना है कि कहीं भी मुझे इस तरह की फंक्शन दिख जाए, सो ट्राई टू सब्स्टिट्यूट ट्रिग्नोमेट्रिक सब्स्टिट्यूशन, एंड उसमें भी some specific value, like अगर x square minus a square है, then we have to substitute a sec theta a cosec theta and all that. And wherever like root under a minus x, root under a plus x, so try to substitute x is equal to a cos theta. These are some helpful substitution जो आपको एक कॉम्प्लेक्स इंटीग्रेंड को फेवरेबल इंटीग्रेंड में कन्वर्ट करने में हेल्प करेगी. आई होप यू ऑल अंडरस्टैंड दैट कि मैं क्या बोल रहा हूँ. दीज आर जस्ट दी सब्स्टिट्यूशन ही हो रहा. हमने जो टेक्निक ऑफ इंटीग्रेशन पढ़ा था उसमें सब्स्टिट्यूशन मेथड था एंड द बाय पार्ट्स था. तो सब्स्टिट्यूशन में क्या सब्स्टिट्यूट करनी है वहां तो हमें पता चल जा रहा था, क्योंकि बाई साइड में ही उसकी डिफरेंशिएशन दिख रही होती थी. बट समटाइम क्या हुआ कि फंक्शन होगा बट उसका बाय डिफरेंशिएशन जो है वो साइड में नहीं दिख रही होंगी. then what we have to do certain substitution, certain specific substitution, and that are as mentioned here. So if we like, if the function look like x minus a b minus x, so we have to substitute like x is equal to a sin square theta plus b cos square theta, जिससे हमारी कॉम्प्लेक्स इंटीग्रेंड फेवरेबल इंटीग्रल में कन्वर्ट हो जाएगी. अभी समझ में नहीं आ रहा है, कोई बात नहीं है. वी डिस्कस हम ईच एंड एवरी सिंगल प्रॉपर्टी पे, या जो भी बेसिक फॉर्मूले हैं उस पर अपन अपनी क्वेश्चन डिस्कस करेंगे, तो वो चीजें समझ में आ जाएंगी. लाइक कैसे अप्लाई करते हैं वो सारे, लाइक रूट अंडर एक्स माइनस ए बी माइनस एक्स होगा, तो ट्राई टू सब्स्टिट्यूट एक्स इज इक्वल टू ए साइन स्क्वायर थीटा प्लस बी कॉस स्क्वायर थीटा एंड ऑल. Now, the next thing is, if the function of the form root under x minus a, x minus b, and so what we have to substitute here? So we have to substitute here like x is equal to a sec square theta minus b tan square theta. So try to remember this और प्रैक्टिस करके ध्यान में हो जाएगा. अभी क्वेश्चन देखेंगे तो चीजें समझ में आने भी लगेंगी. ओके, सो नाउ लेट्स मूव ऑन टू द सम नेक्स्ट प्रॉब्लम. लाइक अगर हमारा फंक्शन गिवन फंक्शन रूट अंडर एक्स बाई एक्स माइनस ए और रूट अंडर एक्स माइनस ए बाई एक्स रूट अंडर एक्स इंटू एक्स माइनस ए के फॉर्म में हो, सो ट्राई टू सब्स्टिट्यूट ए सेक स्क्वायर थीटा. अब यहाँ पे लाइक याद भी नहीं करने की जरूरत होती है, वो खुद से समझ में आ जाएगा. बेसिकली ये आ कैसे रहा है वो मैं एक बार बता देता हूँ सम आइडिया के लिए. तो ये एक्चुअली आ ऐसे रहा है. लुक एट दिस. 4-5 ही फॉर्मूले हम यूज कर रहे हैं जो बेसिक ऑफ ट्रिग्नोमेट्री है. आई विल ट्राई टू एक्सप्लेन यू. पहला है साइन स्क्वायर थीटा प्लस कॉस स्क्वायर थीटा इज इक्वल टू 1. ये होता है. दूसरी होती है 1 प्लस tan square. T stand for tan. Try to remember that. Or shorthand notation of mine. So 1 plus tan square theta is equal to sec square theta, whatever it is. And then 1 plus cot square is equal to cosec square. So if you look here, here, या फिर कहीं पे भी जिसमें भी आपको डाउट हो रहा है आप देख सकते हो. The given problem is like root under x by x minus a. Okay. So if I substitute here a sec square theta, so look at here, a sec square theta minus a, that's count to a sec square theta minus 1. ये tan में convert हो रही है. And we know that the differentiation of tan theta is sec square theta, right? Sin theta and cos theta भी एक दूसरे का डिफरेंशिएशन से रिलेटेड है. tan theta and sec theta भी एक दूसरे के डिफरेंशिएशन से रिलेटेड है. And cot theta and cosec theta भी एक दूसरे के डिफरेंशिएशन से रिलेटेड है. What is the differentiation of cot theta? We know that the differentiation of cot theta will be like minus cosec square theta, right? So we are just using these formula, these basic trigonometric formula, and whatever we get function, we try to substitute here to convert a complex integrand to favorable integral. I hope ये trigonometric substitution समझ में आ गया और एक बेसिक आइडिया भी लग गया कि ये आया कैसे कैसे सब्स्टिट्यूट इन चीजों को कर रहे हैं. तो आई गेस ये भी समझ में आ गया होगा. लेट्स मूव ऑन टू द जो आज हमें पढ़ना था, विच इज स्टैंडर्ड अलजेब्राइक इंटीग्रेशन. कुछ बेसिक स्टैंडर्ड अलजेब्राइक फॉर्म है जिसके बेसिकली उसको बेसिक फॉर्मूले की तरह भी देख सकते हैं. तो या तो लाइक अभी तक हम क्या करते आ रहे हैं, हमने बेसिक फॉर्मूले जो भी पढ़े हैं, जो भी इंटीग्रेंट हमारा दिया होता है वो वी ट्राई टू कन्वर्ट दोज इंटीग्रेंट टू दोज बेसिक फॉर्मूला जो हमने पढ़ा है उस इंटीग्रेंट में ट्राई टू कन्वर्ट करते हैं. एंड कुछ प्रॉपर्टी लगाते जो हमने पहली क्लास में पढ़ा था. तो बेसिक अभी भी हम लोग वही करेंगे. लाइक कुछ स्टैंडर्ड अलजेब्राइक इंटीग्रेशन है और वी ट्राई टू कन्वर्ट एनी अदर अलजेब्राइक फंक्शन टू दोज स्टैंडर्ड अलजेब्राइक इंटीग्रेशन और इंटीग्रेंट व्हाटएवर इट इज. बेसिकली कहने का मतलब ये है कि जो भी हम अभी तक कर क्या रहे हैं कि जितने भी इंटीग्रेंट आते थे, जितने भी कॉम्प्लेक्स इंटीग्रेंट आते थे, वी फाइनली वांट कि मेरे को फेवरेबल इंटीग्रेंट मिले जो कि बेसिक फॉर्मूले से मैच हो रहा हो. लाइक और कुछ प्रॉपर्टी से इजीली सॉल्व हो जा रहा है, जिसके लिए हमने दो टेक्निक अभी तक पढ़ रखा है. एक सब्स्टिट्यूशन था और दूसरा बाय पार्ट्स था. अगर फंक्शन अलजेब्राइक आए कहीं पे भी कॉम्प्लेक्स अलजेब्राइक फंक्शन, सो वी हैव सम स्टैंडर्ड अलजेब्राइक इंटीग्रेशन जिसको we try to convert it into. So like पहला standard form ये है, look like it. Let me write here, and we prove also. Okay, so don't try to worry. So dx by x square minus a square. So its integration is 1 by 2a ln x minus a by x plus a. Now कैसे आया? So we know that अभी हमने just ऊपर पढ़ा है trigonometric substitution, right? So look at this, x square minus a square type किया ना, तो if we substitute here, look at the trigonometric substitution once, कि हमें क्या यहाँ पे substitute करनी चाहिए. Wait, sorry for that. Okay, so trigonometric substitution में अगर हम देखते हैं तो हमें क्या substitute करनी चाहिए. If a square minus x square की टर्म आती है कहीं पे भी रूट अंडर a square minus x square की, so we have to substitute x is equal to a sin theta or x is equal to a cos theta, right? Either we have to substitute x is equal to a sin theta or x is equal to a cos theta whenever the term is root under of a square minus x square type. So what I do here, so let me go through our standard algebraic integration. So here we can substitute x is equal to either a sin theta or a cos theta. So let us substitute x is equal to a sin theta. So we know that the dx is equal to a cos theta d theta, right? Okay. So if we substitute, so our new integrand look like dx is equal to like a cos theta d theta divided by x be like a sin square theta, so a square sin square theta minus a square. So it will be like cos theta, a cos theta d theta, and we know that this will be comes like minus of cos square theta minus of a square cos square theta. And when we integrate that, what it's come like 1 by minus 1 by a cos theta d theta, right? And this turns into 1 by a sec theta d theta. And we know that the difference is, and we know that the integration of sec theta is ln sec theta tan theta. I hope you'll all learn that, or we can write it also in the form of pi by 4. So that's not efficient here. We try to write it in the form of ln form. Okay, so we can also write it as minus 1 by a, okay, ln mod of sec theta plus tan theta. Okay, this is our integration, right? And now move on to the our substitution part. What we substitute here, हमें पता है कि लास्ट में we have to convert these part into x part. ठीक है, क्योंकि हमने सब्स्टिट्यूट करके इसे थीटा के फॉर्म में लिया है, बट वी हैव टू कन्वर्ट इट इनटू दिस. सो व्हाट वी डू, वी जस्ट सिंपली we can write it as minus 1 by a ln, we can write this as 1 by cos theta plus sin by cos theta. So we can have minus 1 by a ln 1 plus sin by cos theta, right? And when we look for 1 plus sin theta, how it look like? 1 plus sin theta. Can you imagine how it look like? So 1 plus sin theta will be if we try to convert this into 1 plus sine theta, so x by a is our sine theta. And so try to convert 1 plus x by a is our 1 plus sine theta. And then cos theta will be, this will be my sine theta. So try to, when we find the cos theta, apply 1 minus uh, basically sine square theta, root over 1 minus sine square theta. And when we apply that, 1 minus 1 plus x by a whole square. And when we solve that, we get 1 minus x by a. Okay. So when we write that, so what I get, 1 by a ln mod of 1 minus 1 plus x by a, 1 minus x by a. And when we solve that, what we get, minus 1 by a ln a plus x by a minus x mod. And then here we go, and then here we get 2a. So what we get, 1 by 2 here. So minus 1 by 2a ln a plus x by a minus x. Whatever it is, it's inside mod, कुछ भी हो सकता है. So I'm saying that कि a plus x by a minus x. So when we use the basic logarithmic property, and we know that when we interchange, so a minus sign comes out, so it will be converted into plus 1 by 2a x minus a by a minus x. So I hope you'll all understand that, like how to. So this is a basic proof. So don't try to remember it. Just try to think कि मैं बस ये कनेक्ट करके दिखा रहा था कि अगर एक्स स्क्वायर माइनस ए स्क्वायर टाइप की फंक्शन होती थी, तो अभी हमने देखा कि ट्रिग्नोमेट्रिक सब्स्टिट्यूशन में एक्स को ए साइन थीटा पुट करते हैं, तो वो पुट करके हमने देखा. सो वी रीच द फाइनल रिजल्ट. I hope you'll all understand that. So try to remember these formula because it's the basic of standard algebraic integration. So आगे जितने भी complex integrand आएंगे algebraic function का, so we try to convert those integrand to the standard algebraic integration. Now next part is same question, just माइनस साइन यहाँ पे कॉमन ले रखा है हमने. सो इट विल बिकम लाइक ln mod of a plus x by a minus. Just invert this. I hope you'll all understand that. If not, then let me. Okay. We just write this part as minus. We just write this part as minus of dx integration x square minus a square, right? And right now we हमें अभी निकाला कि its integration is so minus 1 by 2a ln x minus a by x plus a. And when we apply just a simple logarithmic property, so it's इसकी इनवर्स हो जाती है, पावर में चला जाता है ना ये. So ln x plus a by x minus a, whatever it is, because it's inside the mod, so it doesn't matter. It's automatically give you result in the positive value. So I either you do x minus a or you do x plus a, it's not matter. So now we move to the next standard algebraic integration form. Okay. So our third form is like x square plus a square. So हमने अभी भी पढ़ा है कि अगर कहीं भी x square plus a square रूट अंडर x square plus a square का टर्म होता है, so what we substitute x is equal to tan theta. अगर इस क्वेश्चन को आपने x is equal to a tan theta रख के सब्स्टिट्यूट करके सॉल्व करा, then you automatically get this result 1 by a tan inverse x by a. Automatically, because दिस इज जो हमने भी सब्स्टिट्यूशन पढ़ा ना, उससे ये प्रॉब्लम, ये कॉम्प्लेक्स इंटीग्रेंड है अल्जेब्राइक का. सो वी ट्राई टू convert this into our favorable integrand with the help of substitution. So हमने अभी पढ़ा कि अगर इस टाइप का फंक्शन हो, so we substitute x is equal to a tan theta, and when you substitute that, you get the result 1 by a tan inverse x by a. So let me do it. और एक दो बाकी खुद से भी ट्राई करनी है. So if we substitute x is equal to a tan theta here, so what we get, x is equal to a tan theta, right? So what is dx actually? So our dx is look like a sec square theta d theta, right? And our new integrand look like a sec square theta d theta divided by x square plus a square. So a square tan square theta plus a square. So it will be like 1 by a, and 1 plus tan square theta will be like sec square theta. So it will be like d theta. And when we integrate that, 1 by a theta by a plus constant. So this is our integration, right? Theta by a plus constant. So how to replace this theta by x? So as we move from here, the x by a value is tan theta. And when we take inverse of that, so we'll be get tan inverse x by a value theta. And when we substitute here, what we get? 1 by a tan inverse x by a plus c. I hope you'll all understand that. Basically, just the proof of it. So let me raise it. So now the next problem is dx by root under a square minus x square. So we know that अगर इस तरह कहीं भी function रहे, so what we substitute? We substitute a is equal to let me write here. What we substitute? We substitute a is equal to sec theta. X is equal to x is equal to sin theta और cos theta. ठीक है, रूट रहे या फिर नॉर्मल रहे तो रूट a स्क्वायर माइनस एक्स स्क्वायर पे we substitute x is equal to a sin theta और cos theta. So try to substitute that, आंसर आ जाएंगे. ठीक है, जस्ट फोकस ऑन द बेसिक ट्रिग्नोमेट्रिक सब्स्टिट्यूशन जो हमने पहले पढ़ा, उसी पे ये सारे चीजें हो रही हैं. जो हमने पढ़ा बेसिक ट्रिग्नोमेट्रिक सब्स्टिट्यूशन, उसी पे ये सारी अलजेब्राइक स्टैंडर्ड जो फॉर्म है वो जा रही है. और नेक्स्ट क्लास में हमें काफी सारे कॉम्प्लेक्स अलजेब्राइक फंक्शन देखने को मिलेंगे. सो वी ट्राई टू कन्वर्ट दोज फंक्शन इनटू दीज सिंपल अलजेब्राइक स्टैंडर्ड जो है फॉर्मूले, उस पे वी ट्राई टू ब्रेक. सो नाउ मूव टू द नेक्स्ट फॉर्मूला और स्टैंडर्ड फॉर्म. सो द नेक्स्ट फॉर्म इज लाइक dx by a square plus x square. dx by a square plus x square. So what we substitute here? We substitute here x is equal to a tan theta. Because if we substitute, it's converted into sec square theta, and उसकी integration लेना easy हो जाएगी. So if we substitute here x is equal to a tan theta, it will be solved easily. So try to solve it. I think हो जाएगा. And we get final result as this. So try to remember these results. These results are very important. So try to remember. The sixth question, the sixth standard form is, let me go to the sixth form. यहाँ पे भी सेम ही है. यहाँ पे भी हमें थोड़ी सी बस ये पता करना है कि हमें सब्स्टिट्यूट क्या करना है. Like our form is x square minus a square. So try to substitute here a sec theta. A sec theta. Here x is equal to a tan theta. जो भी सब्स्टिट्यूशन में लिखी हुई है, try to substitute here. ये solve जाएगा. I hope you'll all understand that. Like here root under a square minus x square. So it integration will be like x by 2 root under a square minus x square plus a square by 2 plus sin inverse x by a. So first try to remember it and then try to prove it by substitution of, because it look like a square minus x square. So try to substitute here x is equal to a sine theta. Because this is a one try, x is equal to a sine theta. When we substitute here, we got the favorable result in easy manner. बेसिकली जो कॉम्प्लेक्स इंटीग्रेंड है वो एक फेवरेबल में कन्वर्ट हो जाएगा. ओके, so this is our so what you have to do, just remember the basic trigonometric substitution and some basic algebraic standard form. So our next form are, I think it's ended. Okay, so our next form are root under, so our next form are like x root under x square plus a square. So what we have to substitute here, we have to substitute here x is equal to a tan theta. And when we substitute this, we get a simple integral, जिसे simple integral जिसे हम आसानी से integrate कर सकते हैं. So try to substitute x is equal to इतना and try to solve it. You can easily get this result. And here you can try to substitute x is equal to sec theta, a sec theta, and then you get this favorable result. I hope you'll all understand that. एक दो मैंने करके दिखाया and so try to solve this. Now let's move on to the next part. Using above 9 formula, we can now integrate a function of any kind, like 1 by quadratic function, 1 by root over quadratic function. So what we do actually, look at here. Let me write here. Like we just read a formula of like 1 by x square minus a square integration, like 1 by 2a ln mod of x minus a, whatever it is, x minus a by x plus a dx plus constant, right? Whatever we read here, let me show you. Look at this. Dx by x square minus a square. So what we read, 1 by 2a ln x minus a by x plus a. So look at a very basic example in it. So जिससे चीजें समझ में आ जाएंगी कि नेक्स्ट क्लास में हमने कैसा कैसा प्रॉब्लम को सॉल्व करनी है. So let us take an example which is look like something like that. There is a algebraic function given, something like x square plus 4x plus 5 or plus 3. Okay, and dx. So we know that we can write this function as x plus 2 की whole square minus 1. X plus 2 की whole square क्या होती है? A square plus b square plus 2ab, which is look like 4x. And we minus 1, we get the same result, right? And this integral is of our form integration of 1 by x square minus a square, where a is equal to 1, right? And we know the integration of this part is 1 by 2a ln mod of x minus a by x plus a plus constant. So this is the complex function, complex quadratic function given in denominator, and we can easily solve this problem with the help of standard algebraic form. I hope you'll all understand that what I'm saying. We can easily solve this question by applying the basic standard form or using trigonometric substitution, क्योंकि trigonometric substitution से ही algebraic standard form आया है. अभी हमने एक दो प्रॉब्लम को प्रूव करा है, एक्चुअली दो तीन को करा है. एंड सो ट्राई टू रिमेम्बर दिस. नेक्स्ट क्लास में ऐसी ऐसी प्रॉब्लम और भी टफ कैटेगरीज में भी डिस्कस, जिसे हमें बस करनी यही है. फाइनल एम हमारा ये है कि वी ट्राई टू कन्वर्ट दोज कॉम्प्लेक्स algebraic function into these standard algebraic integral. So now move to the next part. Okay, so we go through the proof here, like x square minus a square को we can also prove it as, like हमने अभी क्या करा था, we prove it by, हमने कैसे प्रूव करा था, हमने प्रूव करा था सब्स्टिट्यूशन मेथड लगा के. Like substitution method we apply, we can also apply some simple manipulation which certain look like, जैसे substitution method हमने लगाया, हमने कनेक्ट करा कि कैसे x को, अगर कोई फंक्शन a स्क्वायर माइनस एक्स स्क्वायर के टर्म में है, सो वी कैन सब्स्टिट्यूट x एज a sin थीटा और a cos थीटा, और वी कैन बेसिकली कनेक्ट करा था हमने वहां पे. वी कैन ऑल्सो सॉल्व इट बाई सिंपल मैनिपुलेशन, लाइक यहाँ पे 1 लिखी हुई है, सो वी कैन ऑल्सो राइट इट एज this 1 as x plus a minus x of minus a. So in numerator 2 created, so we just divide it by 1 by 2a and then 1 by x plus a into x minus a, and when we just divide it, integration of this function is ln x minus a minus integration of this function is ln x plus a, and we just apply the basic logarithmic property. So we get ln x minus a by x plus a 1 by 2a. So we can also go through that. I hope you'll all understand that what I'm saying. But all problems sometimes can't be solved with this manipulation. So we finally go through the trigonometric substitution by which we prove this statement. क्योंकि कभी कभी ये मैनिपुलेट नहीं कर पाओगे. लाइक लुक एट दिस स्टैंडर्ड फॉर्म. व्हाट इज इट? इट रिटन एज dx by x square plus a square. So you can't break it or manipulate these to solve it in a favorable form, right? So what we do, we have a way of trigonometric substitution. So we know that whenever a given function is the form x square plus a square, so we try to substitute x is equal to a tan theta. So here same x is equal to a tan theta is substituted, so dx is equal to a sec square theta. We also proved this statement earlier. I hope you'll all understand that. I'm just trying to show कि substitution is not the only way, but substitution इस केस में easy हो जाता है. Manipulation sometimes लग जाएगा, easy भी solve हो जाएगा. Like we solve this problem with the help of substitution, but ये manipulation से easily solve हो गया, right? क्योंकि उसमें x को हमने a sec थीटा पुट करा था, whatever it is, and then solve किया था. So but इससे क्या हो गया कि मैनिपुलेट करके 2 लाइन में आया. बट मैनिपुलेशन सब जगह नहीं कर पाओगे, तो दैट्स वाई ट्राई टू अप्लाई सब्स्टिट्यूशन, जिससे कनेक्ट भी हो जाएगा कि कैसे अप्लाई करते हैं, कौन से फंक्शन में कौन सा ट्रिग्नोमेट्रिक सब्स्टिट्यूशन की अप्लाई करते हैं. सो दैट विल बी मोर फेवरेबल. नाउ लेट्स मूव ऑन टू द नेक्स्ट. So these are some proof. So try to look at this proof. Okay. So as I'm saying, wherever the function is root under a square plus x square, so try to put x equal to a tan theta, and we put that, we get integration of a sec theta, and integration of a sec theta is ln sec theta plus tan theta plus c. And now your work is to convert those function into form of x and into the form of x. Okay, so when you convert that, you get those result x by a root under 1 plus x square by a square. So when we solve that, you get this result. And here get some constant like c minus ln a. So these are some constants. We have to try to focus on those variables. So I hope you'll all understand that what I'm saying. So today lecture को अगर क्या बोलते हैं समरी अगर करी जाए तो बेसिकली हमने क्या क्या पढ़ा। हमने बाय पार्ट्स के क्वेश्चन करें और स्पेशल इंटीग्रेंट देखा। दिस इज द इनवर्स ऑफ प्रोडक्ट रूल of differentiation, and then we go through the some basic trigonometric substitution, and then we move to the standard algebraic integration. In tomorrow class we solve first problem related to algebraic integrand, complex algebraic integrand, and then we move to the third technique, which is partial fraction. Thank you.